Good evening. So in this subtopic, we will look into conservation of mechanical energy. In an isolated system, the mechanical energy of a system is the sum of its potential energy and the kinetic energy. Okay. So total energy will be equivalent to the summation of kinetic and potential. So conservation of energy, that means initial total energy will be equivalent to the final energy. Okay. Okay, so for today we will look into example 8. So this is a scenario where we have a bullet, okay, mass given as 5 grams, fired into a wooden block, okay, mass given as 1 kg, suspended from some light wire as shown in figure 4.16. The block is initially at rest. The bullet embeds in the block and together swing through a height of 5.5 centimeter. Okay. So over here, what they want you to do is that calculate the initial speed of the bullet and then the amount of energy lost to the surrounding. Okay. So in order to calculate the initial speed of the bullet, you have two situations over here. First is that the bullet collides with the wooden block. So that means you will have a collision over there, and then it embeds inside the wooden block, and then the wooden block starts to move. Okay. So for the first part, as usual, we derive all the information given. Okay. So first, okay, and then we list out one by one, step by step. Okay. The first part, collision, and then it start to move to a height of 5.5 centimeter. Okay, we need to apply the principle of conservation involving two situations over here. Okay, so first what we do is that we use the conservation of energy. Okay, what happens over here is that kinetic energy converted into potential energy. So by solving this, what we can do is that we can get the total velocity of the bullet and the block, okay, moving together. So once we have the total velocity of the bullet and block, what we can do is that we can apply in the conservation of momentum, okay, where it involves collision. So initially you have bullet, okay, traveling and collides with the block which is at rest. Okay, there you have the common velocity which we have calculated. So by using that, we can calculate the initial velocity of the bullet. Okay, to calculate the energy loss to the surrounding, what we do is that we calculate the total energy. Okay, so initially the bullet moving, then it collides with the block. Okay, so we calculate the difference in the energy, which will end up with 109 joule. Okay, so you need to apply two principles of conservation over here: conservation of energy, okay, conversion from kinetic to potential energy, and also conservation of momentum. Okay, that's all for today. Have a nice day.